Welcome to Conversations with Creative Minds. We have been searching for the meaning of creativity and the role it plays in our daily life. People use creativity to express themselves in different ways, such as writing, painting, poetry, composing music, or innovating new products. Creative minds have never been more relevant than today because of the need to solve our society's dynamic and complex problems. Today, we will speak with Dr. Mabel Idika from Nigeria. She is a mother, author, educationist, and researcher. Her expertise spans chemistry education training, curriculum development, school reforms, and pedagogical innovation. She has a PhD from the University of Ibadan in science education, focusing on using 7E and 8E learning cycle models and visualized case-based learning, VCBL, in chemistry classrooms. In today's complex environment, learning chemistry is vital because it plays an essential role in our lives and touches almost every aspect of human existence in many different ways. Teaching and learning chemistry is difficult, particularly in developing countries, whereas educational resources are minimal. Also, teaching chemistry as an abstract is uninteresting and challenging subject to many students. The traditional teaching methodology has failed to connect chemistry to students' everyday life. Thus, new and innovative educational approaches are needed to compensate for the lack of resources to help chemistry students learn new skills to compete effectively in a rapidly changing global environment.
First of all, permit me to describe what chemistry is. Chemistry is a physical part of science. It's one of the physical sciences that deals with the composition, the properties, the uses of matter. And I'm sure most people know that matter is anything that has mass and occupies space. So basically everything is made of matter. So what we do in chemistry is to actually study how matter actually reacts with other matter. And they do this at the level of the atoms. So it's quite inspiring to do chemistry. I'm not teaching chemistry. I am teaching students who will teach chemistry and of course other sciences. So it's a great inspiration. It's a great feeling to try to get young people to appreciate chemistry and embrace the subject and teach other students or teach other young ones about chemistry. So I really find teaching pre-service chemistry teachers very interesting because I can work with them and guide them and inspire them to be great chemistry teachers. Like I said earlier, matter is everywhere. Well, even our bodies are made up of matter. Matter can be in liquid form, can be in gaseous form, it can be in solid form, and these days, plasma. So the study of how matter interacts is important in everyday life. We see chemistry in the industry, we see chemistry at home, we see chemistry in medicine, in transportation, in practically every facet of life has to do with chemistry. The science of chemistry in everything we do, practically everything we do. Right, so At home, you cook and you put a raw egg in boiling water. You boil for 8 to 10 minutes. Prior to that, if you crack the egg, it would have been in the jelly form. But after subjecting it to heat in the boiling water, you have a solid form of the egg you can eat. So at home, you're doing chemistry. The soaps and detergents that we use at home are produced with the knowledge of chemistry. So go to the industries. If we go to the petroleum, the oil and gas industry, the petrol, the distillation of crude oil is done with the knowledge of chemistry. Paint industries, food manufacturing industries, food, not just food manufacturing, even food preservation is done with the knowledge of chemistry. If we look at medicine, production of drugs, and even the treatment of diseases cannot be done without the knowledge of chemistry. If we also look at transportation, like I said earlier, the fuels produced from the chemical industries, from the oil and gas industries drive our machines, drive our vehicles, planes. So chemistry is, like I said, everywhere. So most students, or the average student, thinks that chemistry is abstract. Chemistry is bulky in nature. Chemistry is a subject you can't relate to. And that's where the teacher comes in. And the teacher can make chemistry attractive to students, basically by, of course, there are many ways, but the most important way is in the methodology of teaching he uses in the class. So if I come to a class and I go to the board and I start talking and just explaining, and I'm not interacting with my students, I am not using analogies, I am not engaging them in experiments, in practical work, we don't have hands-on activities in the classroom, definitely the students will find the class boring and uninteresting, and eventually there will be that perception that the perception of chemistry as a difficult subject will develop or may develop, and that would affect the academic performance eventually. So it's important that a chemistry teacher especially must know how to present chemistry in the way that students are able to see the connections between what you're discussing in class or what you're teaching in class and real life scenarios or real life experiences. A teacher can also present or organize activities for learners to learn by themselves, to discover knowledge by themselves. So it's so important. Of course, there are other ways. Another way that I normally tell my students is, or normally teach them to present in the class, is your outlook, your presentation, your charisma as a chemistry teacher. You have to dress well, you have to understand the subject well, that's called content mastery. You have to know how to present yourself. And when you're explaining or teaching in the class, you need to present chemistry as interesting. And you are the first person who will inspire the students to want to listen to you, to want to learn chemistry, or want to even take it further from that class or from that level, either taking it from the secondary school level or to the tertiary level. So, but if you as a chemistry teacher are not inspiring and you're not motivating, then they are not likely to see chemistry as attractive. There are another way is to use scenarios, to use stories, to use cases, and to use questioning, the questioning method. Just basically get your students to interact. Don't just be the talk or the talk teacher. Get your students to interact in the class. Interact, get their opinions, discuss with them, share your idea, let them share their ideas, and let knowledge be discovered. After all, science is a venture for discovering knowledge. It's a process. It's a process for discovering knowledge. So let your students have that, create that experience, that environment where they would learn, they can learn by themselves. They can discover knowledge, and whether through experimentation or any other activity. Right. So chemistry is an interesting subject, but it can be tough. That's basically true. But a teacher can present chemistry in a way that students can learn how to cope with learning the study of chemistry. So when I try to encourage, or when I teach my pre-service teachers about teaching chemistry in the class, I often get the feeling that, or the impression that it's the environment out there or in the classrooms are not conducive enough for them to teach well, to teach effectively. One of the complaints one of the challenges that is commonly discussed or commonly expressed is the issue of power supply. So if I want to I teach my students to use technology, to try to use technology, because that's one other way that chemistry can be presented in an interesting form, and it can encourage interaction. But there is a problem of power supply. So how do you use your computer in the classroom, or in the classroom when there is no power supply? Or even when there is power supply, it's not stable. Another problem is the high cost of even getting of purchasing the technology. For instance, we have what we call virtual laboratory. We can use virtual laboratory to teach chemistry when we don't want to use the physical reagents and apparatus that are normally used in the lab. So, but how do we get this software? Who pays for them? And on whose laptops? How many teachers have been given laptops by the government? So if I want to speak for the public schools, teachers are not given laptops or computers to work with. In some schools, even when there are computers, they're just lying fallow because there's no electricity to power them. Another factor is the technical know-how. So most times teachers are not well trained to use the technology. Teachers also are not well trained on how to use innovative teaching methodologies and incorporate them in the classrooms. So even when I teach my students I teach them a lot of teaching methodologies they could use in the class, apart from the conventional lecture method. So, but the problem still remains that the structure, the environment is not conducive for them to actually implement these methodologies. And they also have the problem of time. They have the problem of time, and because chemistry is bulky. That's true. Chemistry is bulky, but so there's always this pressure, or there's always this concern about finishing the syllabus on time to get the students ready to write their examinations. So these are part of the problems they face. I basically teach methodology, and that's chemistry methodology or science methodology, to future chemistry teachers, to students who are going out to be chemistry teachers. So like I said earlier, methodology has gone beyond teacher-centered to student-centered. So we are teaching them, I teach them to practice or to implement or to learn how to teach with other methodologies such as inquiry method, the use of technology-based methods, and other innovative methods. But it's difficult for them to actually use these methods because the infrastructure is not there. The structure is not there. The environment is not conducive for that. There's poor funding. Even when they try to use this method, for instance, teaching inquiry, teaching chemistry with inquiry method in this environment is almost impossible. What we do most times is we use improvisation. So we take things from our environment that can serve, so to speak, the same purpose of the standard material. I'll give you an example. I think I have a picture on that. I carried out an experiment in a school, in a public school, and we needed to heat a solution, and there was no Bunsen burner, and there was no gas. So we had to use a local kerosene stove. So we do that. Sometimes where there is no funnel, we use an old feeding bottle, a calibrated feeding bottle. So these are things, these are the issues really. Maintaining a positive culture or positive mindset in the classroom, in an environment where there are limited resources, yes, can be quite challenging. But like I said, I don't just teach my student teachers, I inspire them to be passionate, to love what they are doing. If you don't have a passion for teaching chemistry, the challenges could derail you and cause you to give up and look for another profession or other opportunities to other occupations. So first of all, I try to inspire my teachers to be passionate and exude that passion in the class and outside the class. So I normally encourage them to be open to their students, to try to answer questions, be open to questions and try to attempt to answer the questions or maintain conversations with their students. Because I also teach them that no one is a master of all. Yes, you should know chemistry very well, but no one is a master of all. When you show your students, you can also learn from them. They are more open to what you want to your class. They are open to you. They can discuss their problems with you when they know that you are accessible. A methodology or teaching methodology is, we can say, an approach to how a teacher decides to teach a particular topic or subject in order to achieve meaningful learning. So there are different methods you can adopt in the class to teach a particular topic. I often tell my student teachers to use a variety of methods, because you can't use every one method to teach all topics in chemistry. So there are some topics that would require the demonstration method. There are some topics that would do well if you use the lecture method. There are some topics that you would achieve your set objectives when you use inquiry method, when you use experiments, or when you use questioning. Now, learning cycle is a constructivist-based idea or model that is based on how students learn. And it can be used as basis for developing a strategy. A strategy can be developed using the learning cycle model. So that's basically the difference. Right. So initially we had the four cycle model, and then we had the 5E learning cycle model, which had 5 steps for students to discover scientific knowledge. However, in 2003, a professor of science education, Arthur Eisencraft, expanded 5E to 7E. So he added 2 more levels or 2 more steps. He added the step called elicit and the step called extend. His goal was to ensure what we call transfer of learning. Transfer of learning is that students are able to take what is learned in one situation and use it in another situation, because they see some associations or connections between the 2 situations. Then he included extend, which is to take the knowledge that has been learned in the class a step further in preparation for the next class. So in 2019-20, expanded the 7E learning cycle model to include an 8th step called exhibit. So the 8E learning cycle model has basically eight steps or has 8 steps. And the first step is elicit. In elicit, you try to discover or you try to assess students' prior knowledge. The second step is engage. In this step, what the teacher tries to do or attempts to do is to point or move the students or direct students' thoughts in the direction of the new concept he's about to teach or they're about to teach. Then we have the explore. The explore stage is the stage where the students use their hands and use their scientific skills or develop their scientific skills of manipulation in form of experiments, forming hypotheses or formulating hypotheses and recording their results and making conclusions. So in that stage, students at that stage, students are busy. They're experimenting. Of course, the experiment must have been prepared and designed or arranged by the teacher. Then the next step is a step called explain. At this point, the teacher takes center stage and explains, of course, explains the outcome of the experiments and uses that to provide definitions, explains phenomena and other knowledge that the students need to acquire. Now, at this point, that's where the exhibit stage comes in. Now, usually the next step would have been elaborate, but I decided that before taking the students to the level of elaborate, which I will explain later, it is important to ensure that they do not have what we call alternative conceptions or misconceptions. I'll give you an example. The students some students mistake melting for dissolving. So a teacher who in an 8E class at this exhibit stage, the teacher presents a statement like, so is heating the same thing, is melting the same thing as dissolving? Now, this statement is what we call conceptual change text, CCT. So the exhibit stage is a stage where we present the CCT to the learners and allow them exhibit either misconception or real conception of, or the real idea of that concept, or the real meaning or the correct concept. Now, at this stage, we don't tell the students they are wrong. What we do is to listen to their opinions and then give explanations or scenarios or cases to show that or to justify the CCT or to disprove the CCT. So at the end of that exhibit, everyone in the class comes to the point where we have the right idea or knowledge about this concept. And then we move to the next stage called elaborate. At the point of elaborate, we give students or learners opportunity to apply. So at this point, you can give a task. It could be a classwork. It could be an activity for them to apply the knowledge of the concept they have just learned. And then we move to evaluate. Evaluate is the point where the teacher assesses the students to know if his set objectives have been achieved. And then the last stage is extend, where you either give, as a teacher, you give a project or assignment or weather group or group-based or individual basis in preparation for the next concept that is to be learned, or to strengthen their knowledge, deepen their understanding of the concept you have just taught. 8E learning cycle model based strategy is constructivist in nature. It's based on the theory of constructivism. And this theory posits that learners can construct their own learning. So it puts you, a teacher, in the place or the position of a facilitator, of a guide, of a director, so to speak, but not the sole source of information, not the sole source of knowledge. So it's not a unidirectional, but a multi-directional. I say multi-directional, not bidirectional, because it's interaction between teacher, learners, materials, teachers, materials, learners, learners, materials, and it goes those ways. There's this pyramid of learning that explains how learners retain information, or how much information learners retain. And that pyramid, or that cone, is actually a cone, is called the cone of experience. It describes how much information learners retain at the end, depending on the learning experience provided. So all through, of course, the widest or the largest percentage of retention of information is at the bottom of that cone, because at that point we have 90% of what is taught is retained by learners. Across the cone, from top to bottom, there is one experience or means of learning or means of acquiring knowledge that cuts across from the top to the bottom, and that is the use of the eyes. So whether you're reading, or you're watching a video, or you're listening, or you're hearing and listening, or you're going on an excursion, a field trip, or you're doing hands-on, or you're in a simulator, or you're in a virtual lab, basically it's the sense of seeing that runs through across that cone. So what does that mean? What does that say? It basically says that what we see, the seeing is very important. So how do we make chemistry, how do we help our students to retain the knowledge of chemistry? Is to encourage, or is to encourage teachers to present the concept in visuals, either in charts, like you can see behind me, there's a periodic table, or in movies or videos, something. And even with real objects, they have to see. Before they can even manipulate those objects, they have to see. So visualization is so important. When you see, it registers in the memory. So it's important. Visualization is very important for retention, or acquisition and retention of knowledge or information. So visualized case-based learning is a strategy that I developed for enhancing students' learning outcomes in chemistry. So it's a strategy. Basically, the case-based learning is the use of cases to teach students, to teach a subject or to teach a topic. Now, cases are basically just scenarios that give a picture of the idea that, or the concept, or the meaning, or the definition or description of the concept that you're teaching or that you intend to teach. So these cases are, even though they are real life, they can be formulated by the teachers. So what I did with visualized case-based was not just to present these cases to the learners because it can be presented to them in paper form, in print form. It can be narrated orally, but I thought that it would make more sense and have more lasting impact in terms of effectiveness, and that it would be better to have the cases presented in videos where learners can watch these videos, relate with them, and or try to solve the questions or problems that follow the cases. These problems or questions are not right or wrong answers. They are not for evaluating the students. They are for the students to also express their opinions, express their minds and thoughts. So it makes them develop their reasoning skills, their critical thinking skills, and their problem-solving skills. And this is what we want to achieve with teaching chemistry. We want our students to be thinkers, because thinkers become innovators, thinkers become inventors. If our students are not thinking, and that's what I teach my student teachers to do in their classrooms, encourage your students to think. Encourage your students to question. It's even a scientific attitude. You have to think, you have to question the status quo, you have to observe and make your own opinions and make your own findings and test your findings or test your observations and make your own conclusions or inferences. My life is an interesting one. Every day there's something new. It's an interesting work because, like I said, each day I'm open to something new. I like to learn. So, and I'm an organized, I can say I'm an organized person. I can't afford not to be organized because, like you've already mentioned, I'm a wife and I have a daughter who is in the 6th grade. So it's basically taking her to school, preparing to take her to school every morning and get to the office. And my students start coming in when I don't have a class. And when I do have a class, I take to my lectures, to give lectures in class and do the things in between that, inspiring them. My students come to me with questions, and both personal and academic, and I help out as much as I can. I have a lot of young learners because I basically teach the 100 level students and the 200 level students. Of course, I have students in the master's class. So I do a lot of motivating. I do a lot of encouraging. I do a lot of inspiring. I do a lot of correcting and guiding and directing, just basically to help them. I love to see the people around me do well. That's whether you're my biological child or a student or a colleague. And then when it's time to go to church, usually in the evening, I could have rehearsal, choir rehearsal. So I teach songs and I teach people how to sing. I encourage them to sing well. I'm almost a perfectionist with singing. So sometimes they look at my eyes when they're singing because they know I'm going to correct them. I'm going to stop you if you're singing off key and stuff like that. But it's an interesting life I live, supporting my husband. He's an engineer. So he's not a teacher like me, so we have different paths, but I try to support his work, his career, and give him the advice I can when I do. And I also do trainings for teachers. Like I'm a facilitator. I have a consulting firm too. That from time to time I go to schools to give them ideas or solutions to their problems, ranging from teacher training to school management and administration and stuff like that. So that's basically how life goes. I would love, right. So I would love that we have positive, productive collaborations. So what we already have or what we already know, we could share, and those from the developed nations can also share their expertise, knowledge. They can share their resources with us. One of the most important ways that comes to mind right now is capacity building. I would love that the science educationists science educators or chemistry educators in the developed world can, find a way of teaching us or training me and my colleagues so we can improve professionally and gain more knowledge about pedagogy and chemistry education. Because whether we like it or not, there's a constant evolution of global trends in pedagogy. And we don't want to be left behind. I wouldn't want our chemistry teachers or my fellow chemistry teachers or chemistry educators and science educators in general to be left behind. So I would appeal to the developed countries or our colleagues or counterparts in the developed nations to find a way of sharing or training us, giving us some form of capacity training, capacity building programs where we can get abreast with the trends, the latest trends, so our students will not be left behind. I think that's one of the Sustainable Development Goals, access to education and quality education. So if we are not getting quality education here, I think it's going to be a problem for the world, because globalization has brought or is bringing everybody to a small space, and we don't want our students to not fit in to that space. I believe that Nigerian chemistry students can also become solution providers to global issues, to global problems like poverty, global warming, food shortage, migration, issues with migration and things like that. But if the teachers are not equipped to produce such students, then we can't have them.